BTech from IET Lucknow in Computer Science, MS in Software Systems from BITS Pilani, and PhD from IIT Roorkee. His research area include distributed systems, computer network, IoT, fault-tolerant systems, and real-time scheduling. During his academic career, he has supervised many theses for masters and several theses for PhD. Over the years, he has got several publications in international journal as well as various conferences held at national and international level. He has organized many workshops, FDPs, and delivered expert talks at various platforms. I would now request Sir to start his session.
Okay. The screen is visible? Hello.
Yes, sir.
The screen is visible?
Sir, not yet.
Hello.
No, sir, not yet. Your screen is not sharing.
Hey, I have shared a screen. The screen share and then desktop. Share sound, share. Zoom will share your screen, open the preference, security, privacy. Desktop, location, Google Chrome. Desktop.
So you must be seeing the screen share option in green. So then click on that.
We have clicked.
Sir, then what you are getting?
A desktop, whiteboard, icon via cable. So desktop one is I am clicking share.
Yes, sir. So you have already opened the PPT in the desktop. It should be open also.
It is open.
Okay, sir.
PPT is open. It is asking open system preference.
Sir, according to me, when you are clicking on sharing screen, you would be getting several tabs in which there will be one screen or whiteboard or iPhone pad. And if you have opened the presentation that you are going to display to us, then it would be also displaying on the same tab. Means you will be getting multiple tabs which you have already opened.
No, I have opened my PPT. It is visible to me.
Okay.
Open system preference. For open system preference. Can I send you mail? You can share.
Sure, sir. We'll do that.
I have sent. You have got.
Okay, sir. We'll be sharing. Just wait. So we have shared the PPT.
Okay, okay. So let us start this. Today, first of all, I say thanks to the GL Bajaj committee member for giving me opportunity to share my views over IoT security. Overview which we are planning to cover over this talk, overview of IoT, scope and benefits of IoT, IoT security concern, IoT security issues, IoT security challenges, effort to rescue IoT devices, way to protect the IoT devices against the cyber criminals, cyber crimes, and at the last, we will quote from where references from where we have taken this material. At the beginning, I would like to tell you these are material collected somewhere at different sites. So I will refer that one in the references. If we see Internet of a Thing today, if we just go back around 30 years back when we were doing our BTech started journey in computer science at 90. At that time, nothing was interconnected. Everything, in order to communicate someone, we are required to write a letter reaches to that person, and it takes around 1 week. And if that person has written the letter, then it becomes 1 week to reach them. It means that total communications among two parties takes 15 days. Within 15 days, we do not know what's happening. But the advancement in communication technology, mobile phone, internet, and other facilities are there, so that today we have everything over our thumbs. Whatever we want to know, we have to go in the internet, search the Google Drive, and get many things as we require. In this way, if you know Internet of the things, so today things are getting more and more easy to have. So among the data availability, we are talking about big data. In this big data, one aspect is mining of the data. That's why data science is one of the objective in today for managing the big data, and that is Pythons and other programming languages are getting to. But we are not concerned all aspects of the data sciences, and data science at the heart of this particular FDP is very recent, and many universities and even IITs and other ones trying to start BTech in data sciences that is getting more and more popularity than its generic BTech IT and BTech computer science, because more and more job opportunities are there for managing the data. Internet of a thing. So today we have internet. Now we are talking about Internet of the things, multimedia of the things. What is this? In the Internet of the things, it is an embedded system. Today, if you see, embedded is a today era. Everything what we are planning, what we are designing, based on the embedded technology. Why this embedded technology is getting more and more popularities? Because if you know, whenever you design any model, any system, it's require proper testing, proper validations, and one is company testing and one is real-time testing. Just like you are aware, many model of a particular items came, some model survives, some model not survive. Some model get opportunity, have a wider range of the applications, user, and some model does not have opportunity, and even it could not get a ample amount of user. So that's why in embedded technology, instead of designing whole as one, whatever we are doing, we try to create another a small dedicated system that we design, we test, and we put that designed new system in the existing one. Whenever we are designing this embedded system, it is very, very specific task-oriented system. And when you put this system in existing one, it may be possible that if this system is slow, entire performance of the system is gone. So in the embedded system, very, very specific task is added and adding the stars, creating new one. Because in today's environment, if you think no device has longer durations of its life, things are changing. If I compare the price, the starting computer price in 1986, 90, that price was around 33 to 40,000. And today, if we are talking about PC, its price is again 40,000. So IoT in the market, if you look at this one, here you can see how this IoT is getting the popularity. Here we have short range IoT and we have wide range of IoT. In this short range of IoT, it is getting popularity. However, IoT for wide area network, wide area, it is getting more and more popularity. If you start from the data as it is given, millions in unit in 2014, we have wide range 2728, and in 2024, that is predicted data based on the extrapolations and nature of the rising, it would become 17,797, approximate 18,000. So from 3,000 approximate, it reaches to 18,000, more than 3 times. Similarly, starting from short range of IoT, 245 million, it starts, and now in 2024, we are expecting this as 4,372. It means it is 10 times. So if you compare the growth rate, although the data is in millions, it is triple in short wide range. However, in short range, it is 10 times. So now we are talking about IoT in global market. It would be worthless if we say, what is the global market of the IoT? Consumer as well as industrial. So star data is forecasted. Star data is forecasted. This data is given by SGMA intelligence source, and in 2018 to 2025, so all the data which is written as a star, because this data is somewhere generated in 2019. So 20 and 21 data itself is a star, predicted one. So if you see here, billions of the objects in billions, starting from consumer, starting in 2018, 5.4, in 2025, it would be 11.4. Similarly, industrial 3.7 to 13.7. So here it shows that this IoT market is also at the global level. It is also capturing good amount of sharing and good amount of customer, both at industrial as well as the consumer level. IoT market in top of the countries here in the billions of the US dollar by 2020, 29.5 billion connected devices would be there. Globally, 8.6 billion connected devices as APJ. 1 out of 5 every connected device will be from China, and market opportunities 583 billion. Top countries of IoT span. Here, one has to see China is at the top, South Korea is next, India is backing at the third position, followed by Australia and Indonesia. And top industries, government, utility, discrete manufacturing, healthcare. Today, this IoT device is playing a vital role in the area of the healthcare. People are talking about IoT device and they are planning to a body area network as one of the stream where they implant some of the sensor in a body that sense something and predict sometime it is able to predict the disease which is able to come in near future, maybe after 10 years, after 5 years, like that. Retail market is also based on the IoT. Opportunity. It would be worthless if we do not discuss about the opportunity here. IoT opportunity for technology service provider. This is 2020 data and it is reported in billion. So here, if you see hardware backed by 31%, communication networking 17%, computer storage is 18%, and big chunk of this 3 to 8 billion US dollar going to the software compatibility, capability, services and analysis. And in this IoT applications, Internet of the Things, here we have a process linking relevant information to the right persons at the right time. Because here, today's scenario, no one has time for choosing the data. Everyone requires the data to be processed and labeled as per their needs so that digested data can be used. People providing visualizations and data utilization, getting the useful and actionable sites and things it is developing. So here, IoT applications, if you look, one is driver, personal interest. In that way, consumer IoT, health and fitness monitoring. Today, how much energy you have burned, how much energy you have taken, how much disease you have taken. And many times we are talking that we, for a diabetic person, how much insulin is required. We put up a IoT devices in sensor in the body and that bottle, it will monitor the body requirement and secrete that amount of insulin. So health monitoring and filtering, home automation. Here, everybody is familiar with home automations, IoT devices applications, industrial IoT, business driver is business interest, business value, retail automations, connected vehicles. Today, we have connected vehicles that are run by this particular network. And so that we are able to have the information and availability of this one. Smart city, one of the major goal of our Honorable Prime Minister, smart city. So in the smart city, IoT is also playing a vital role there. So IoT applications are at the consumer level, interest is personal, where in health and home automation, at the industrial level, where business value is the role, retail automations, connected vehicles, smart city. IoT current market and expected in 2030 in terms of the billion US. So 2 million Internet of Things from 90 to 30, it is expected growth of mobile devices 34%, power, connected vehicles 7%, lighting, another one. So here you see, even across the globe, in 2030, IoT connected devices will be for 24.1 billion and total IoT revenue 1.5 trillion. This is expected. So in this one, here you can see over this one, 24% is backed by America, 26% China, and 23% Europe, rest is other country. So here we have vertical specific growth, cross vertical, and other one. So this is the IoT current market and expected in 2030. IoT markets in India, it would be worthless if we do not focus. As we know, India is the greatest market of everything because it has huge amount of population. So India is the good market. So if there is market, then there is a survival. So IoT market in India, if we have from left hand side, IoT market overview in India, and in right hand side, IoT markets in overall global market. If you look at here, 2014 to 2022 expected data, everywhere, both at the India level as well as global level, they are sharing same kind of rise. The rising ratio may be varied, but at the India, it seems more steeper. So here, rising implementations of smart applications, Internet of a Thing, government initiative. So both these three are the drivers of these IoT markets, rising the implementation of smart applications, Internet of a Things, and government initiation. Hardware, software, as we have shown. Then we have a smart city project is the key initiative of the government, as we have said. Implementations of IoT in India, and then India industrial IoT growth at the faster rate, both are shown here, and smart wearable home appliances. Here you see home appliances bags, major share here, and in this IoT, smart healthcare, industrial, and smart meters. Today we are talking about smart meter, connected vehicles. These are the IoT markets in India. Worldwide IoT connected devices, again, IoT connected devices installed worldwide. Again, we have data from 2015 to 2025, and this data is somewhere predicted and somewhere genuine. It also says it keeps on increasing this one. So here you see in 2015, it was 15.41, and in 2025, it would be 75.2. over 1 billion. So this shows how the growth of a particular IoT does. Here, IoT system, example of IoT system. Here we have checked out 3 parts: data collections. Here IoT devices, which here is sensor. IoT device is antenna. IoT device is microcontroller. These 3 are a data collection portions. And then we have IoT hub or IoT gateway, where we have required a network, efficient network as a hub or gateway that transfer these collected data to a desired one. Then another part, look at the more related to the data science, analyze and take actions. So IoT system is example of 3 parts. One is collecting the data, one is collate and transfer, and another one is analysis. In the analysis part, user interface, smartphone, human machines like this one, analysis of business applications. Sometimes in user interface, smartphone, and everybody is talking about security, and security, biometric securities are there that we will discuss later on. So user interface, analytic business applications is another part, and back-end system. These 3 are the part of analyze the data and took actions. IoT components. IoT devices component include the following. Sensor allow IoT device to provide data, reading data from physical world, such as room temperature and motion sensor. Actuator allow to control a physical component moving object, means how much distance you want to take, how much changes you want to take on the basis of your analysis of the sense data that is done by actuator. Network communications with application programming interface, send and receive data from the other devices. User interface provide mechanism for end user to interact with the device, such as voice controller or touch screen. Management interface that can be used to configure the device, modify settings, including security settings. So these are the components of the IoT. IoT component, if you think of a device, cloud, gateway, user interface, analysis. So major component, again, it is shown in terms of the pictorial things of a device. It is connected to the wireless network, gateway, then the cloud, then the analysis, then the user interface, because at the user interface, user is requiring as per their special need as a digested one. IoT standard, it would be worthless if we do not discuss IoT standard and framework. So IoT standard, it is working over IP version 4 over low power in IP version 4, low power wireless personal area network, because as you see, IoT range is smaller than network range. So low power, because they are operated by battery. So it is low power, wireless, personal area network. It is the standard is 6 yellow pant. This is the software, and this standard is given by Internet Thing Engineering Task Force IETF, and this follow the standard. Zigbee. Zigbee is another standard for IoT. It is a low power, low data rate, wireless network used mainly by industrial settings. Light OS. It is a Unix operating system for wireless. Then we have one machine to machine service layer that can be embedded in software and hardware to connect device for real-time scalable and high performance for machine-to-machine communication. Then we have long-range wide area network is that protocol support huge network such as a smart city with millions of low-power devices covering a wider range than personal area network. So these five IP, low power, Zigbee, light, machine to machine, and long area network. These are some of the standards in the IoT. And for the as far as framework is concerned, if we look and pick up certain one, probably we pick up one of the most prominent framework here is Amazon Web Services. IoT, it is a cloud computing platform. Now you see that web services are sold. Amazon is holding the web services. Services it is holding. We are talking about cloud where nobody want to have a device, it have a work, it borrow it purchase the services and do the work. So IoT cloud computing platform for IoT released by Amazon. Then another one is more popular, followed by Amazon. ARM Embed IoT. It is a platform development type for IoT based on ARM microcontroller. Those who have gone through microprocessor and different kind of, one kind of microcontroller is ARM based, and third one, Microsoft Azure IoT suite. So these are the three framework that we have quoted here as an example, which are more prominent. There are many ones. So IoT standard and framework network. If you look at here, network is at one part, intelligent action is another part, intelligent analysis is another part. We are talking about intelligent analysis because standard is another part, sensor is another one. So IoT component implementation of IoT, it is supporting standard, it is supporting system, network, it is supporting to the sensor, intelligent actions, intelligent analysis. So IoT component implementation, if it is good, it is high, supported everyone. IoT standard and framework. Here, we again try to check out some of the specific case, connectivity, cloud, big data analysis, applications development, connectivity, network infrastructure, wired, Wi-Fi, cellular, standard, Ethernet open, machine-to-machine data acquisitions, embedded gateway API, TCP, device management, complex event processing, alarm condition-based monitoring, data transportation speed, authentication. Then we have a cloud. In the cloud, private, public, and hybrid. Those who are familiar with cloud, they might be knowing private, public, and hybrid cloud. Then we have IaaS, PaaS, SaaS. These are three kind of services: compute, storage, network, runtime queue, and traditional data historian to handle. SaaS, traditional enterprise applications, next generation IoT applications, security, authentications, access control, configurations management, cryptography, logging, checkpointing, data tracking, compliance, big data, statistical program analysis, R, programming, R is one of the language, SAS, SPASS, searching tool we have text mining, data exploration, analytics of the images, video, time series, its prediction, modeling, machine learning, and its visualizations and application development. Today, we are talking about integrated development environment, data model and execution engine, workflow business logic modular, collaboration, social mobility, security authentications, access, control, management, cryptography, log. Then we have IoT platform again, IoT application. At application level, we have logistic, remote monitoring, alert, remote control, maintenance, safety, security, optimizations, automations, intelligence, IoT analysis. We have complex event processing, geospatial system, predicted analysis, holistic analysis, IoT data, enterprise data, social data, IoT developer platform, ID, storage, high scalability is required, no SQL security, middleware we have required workflow, business rules we require, cloud enabling we require, open standard, wide area IoT communication comes here. Cellular, satellite, cable, new waves, private network, device, rate, SIM management, diagnostic. Local communication is supported by Ethernet, Wi-Fi, Bluetooth, or FIT gateway, router, and device is managed by device independent, device cloud, connectors, configuration, local intelligence gateway, things level, sensor data filtering, summarization, pattern detection, intercepting, processing analysis, algorithm, device and bin. So devices and component here, platform and sensor controller like that. Then we have security, encryptions, authentications, access, identity and trust, system integrations, design, implementation, rollout, and support. And here, system integrations, we are required to, as we know, we are living in the era of IoT embedded. So design, implementation, rollout, and its support, all these kind of analysis is required. So these are the IoT platform. IoT standard framework, Internet of Secure Things, secure boot, authentications, secure communications, data protections, firewall, intrusion detections, event reporting, remote command audit, policy management. Here, secure boot, and this can be done with the help of hardware integration. Many times in the IoT devices, it is hardware integrated with crypto and secure IDs. So secure boot, authentication, secure communication, data protection, firewall, intrusion detections, event reporting, remote command audit, policy management. These are supported as we know that IoT devices are supported by very dedicated tasks. It is not in general use. That's why it is hardware integrations of TPM, TE, crypto, and secure ID at each one. So all the things that IoT industrial benefits, if you look at the industrial benefits of IoT, it monitors overall business process, improve the customer experience, save the time and money. That is one of the crucial thing each one has, saving the money, enhance employee productivity. In the IoT, employee productivity is enhanced, integrate and adopt business model. Business model is integrated and adopted easily with the help of IoT, make better business decision. In the IoT, we have our specific decision data, pre-processed data, analysis data. It means that we are able to make better business decisions, generate more revenue. One of the vital applications of IoT, it will enhance generating the revenues, ability to access the information from anywhere. So Internet of the Things, ability to access anywhere at any time, at any device. It means that your locations, your time, your device does not have a vital role. Here, it appears that so there is no restrictions of your positions, your locations, no restrictions of time where you have, and no restrictions of device, how inferior, how good device you have. The IoT industrial benefits provide you accessibility, ability to access the information from anywhere at any time, any device. Improved communications between connected electronic devices. It will provide you improvement in communications between connected electronic devices, transferring data packets over connected device more prominently, thus saving time and energy, money, automation tasks helping to improve quality of business service, reducing the need of human interactions. So these are some of the benefits. IoT devices. Now look at some of the noteworthy devices. So far we have discussed communication component, standard, platform, and some of the well-known IoT devices that we are using at our home. So here we are listing some of the IoT devices. Amazon Echo. This device had a lot of features like playing and audiobook, music, play, voice interaction, making to-do list, setting alarm, streaming, podcast, etc. August doorbell cam. It consistently monitor your door step by speaking with human at your front door. through your phone and provide 24-hour video recording. It means that you can manage this one through your mobile. Aware, it closely monitors the carbon dioxide and track dust level VOC in the air throughout day. It means this is one device that consistently monitor and track all these pollutions in your room and our working place. Belkin Nemo. It provides remote control of home products that includes electrical plug. Today we have a bulb, we have devices which are operating by our mobile. Then we have another one, ring doorbell. This is double clad home network security IoT devices. Allow the user to answer the door using your smartphone. Elgato, it is a domestic automation merchandise work with Apple HomeKit to allow customers to monitor indoor air, outdoor weather, power consumption, whether or not home window door is open or closed. It means LOI Chamberlain MyQ. It permits you to control your presence storage door together with your iPhone and Android tool. X. It is Amazon Intelligent Cloud-based voice services platform. It is a power that entire smart device can be ecosystem. Alexa, you can search, you can operate, and you can put any activity like human being just move searching a particular. So in the real world applications, transport and logistics, fleet management and route tracking is one of the applications of IoT. Then utility, smart metering, smart and grid management. This is the electrical because there is a losses in the power. So it is managing the utility, smart cities, parking, sensor-based parking. Now you see that you have many vehicles that come along with the sensor. So whenever you want to park, they get their locations, and if some vehicle is side by side, they direct us to wastage management, parking sensor. These are the two applications, major application of smart city, smart building, smoke detector, home automations. These are smart building, consumer, wearable, kids and senior tracker, industrial, process monitoring, control, maintenance, monitoring, food monitoring alerts, environmental monitoring, agriculture, climate monitoring, so the particular temperature required for particular crop that could be monitored, and farmer could be suggested accordingly to go on that particular crop. So real world IoT applications, wearable, IoT equipment, virtual glass, fitness band, GPS tracking belt developed by Google, Apple, Samsungs are used to monitor the calories, exercise, heartbeats, other parts of the daily lives. So wearables can have these kind of healthcare. IoT equipment, hospital, smart bed is used to observe this is vital sign, blood pressure, oximeter, body, temperature along with other one. The device embedded with patient allow continuous monitoring even patient is outside the hospital and generate the automate. Agriculture थोड़ा स्लो कर दीजिए भाई, थोड़ा फास्ट नहीं. The device embedded with patient allow continuous monitoring even patient is outside the hospital and generate. So that healthcare applications you can see, in case you remember this COVID, when even doctor is afraid of this COVID and no one was caring, in that case, this IoT devices, if equipment with hospital, it monitor the critical parameter of a body, oximeters, another one, and regulate correspondingly the device embedded with patient. If some patient is discharged, even without his intervention, the device continuously monitor its positions when patient is outside the hospital and generate automatic traffic management. Mobile phone equipment sensor collect and share data from vehicle through applications such as Waze, Google Maps, facility traffic monitoring through sharing the information about route with estimated distance of arrival. It means that in a city, particularly if you want to go at some places to other places, correspondingly you are requiring how much traffic you have and how much time you require. So traffic monitoring and fleet monitoring is one of the real applications we have, so that in the day, which route you want to follow, you are suggested to follow with estimated time and estimated cost. Then we have agriculture as we have. It provides detailed information about soil conditions such as soil moisture, level of acidity, presence of certain nutrients, temperature, etc. required for irrigation, best time to start sowing, its disease and its preventions. These are some of the applications, some of the area where IoT can help in agriculture. Smart home monitor locations in real time, turn on and off and tune the parameter of home devices. Means suppose you go out and you are not in your home, this IoT device may turn on and off, maintain your temperatures of home when you are about to come. Hello. Hello. The screen is not visible?
Yes, sir, it's visible now.
It is visible. So industrial automations, it allows direct integrations between physical world. ये साइड में जो आ रहा है इसको थोड़ा बंद कर दे, स्क्रीन कुछ साइड में जो लोगों के नाम आ रहे हैं ना, इससे कुछ पोर्शन से कट रहा है. हेलो हेलो.
Yes, sir, is it visible now?
No, it is visible, but one portion of the screen you are showing the name of the persons, that hiding some of the content of the slide.
Okay, sir. I have hidden it now.
Okay,
Is it better now?
It's allowed direct integration between physical world and computer-based system, resulting in improved efficiency, accuracy, and economic benefits. Microcontroller. Then we have one of the famous Arduino-based industrial fault detection system. Those who have gone through embedded system, they might be familiar with Arduino-based embedded system. System collect and signal from different sensors and smoke, temperature, LPC gas sensor and send to the IoT module so that you can regulate a particular device in case it is doing some of the misbehavior kind of things. top IoT project going on: smart agriculture system, weather reporting, home automation, face recognitions of the board, smart garage doors, smart alarm clock, air pollution monitoring, smart parking system, smart traffic monitoring, smart cradle system. This is required in today's environment when both mother and fathers are working. Then it requires smart credit system where proper care and recording could be done of a child. Smart gas leakage detection. If there is a leakage, that could be detected through smart device, and everything is here. These projects, some of these projects, in IoT, everything you are monitor from your working place through your mobile or any other device which you are connecting. You are monitoring each and every one, anytime, anywhere, any place. IoT popularity, as we have already seen, revenue pools and IoT use cases both are showing here that it keep on increasing 20% per annum from 2014 to 2018, and then it is increasing 24% in 2023. Means in each 4 year or 5 year, it keeps on increasing 22. It means that each year approximately 6% it is increasing. Then we have ADR 56, 15, 14 like that. And this unit is billions. This shows that how the IoT device is popular in both use cases and revenue generations. Go ahead. While looking this popularity, one might be thinking that it is popular for a particular reason, but here we are saying that West speak America and other one. So by reason 2004 to 14 to 2023, we have popularity, and then we have company-wise, a small company, medium company, and large company. So IoT popularity is not concerned with any reason, any size of the company. It is popular across entire globes and entire level of company. So here, small home office 1.9, some of the measures we have, it is given in that particular portion from where it is collected based on the employee. We are saying big size, small size, medium size. So these are the 2014 to 2023 data. Go ahead, please. Top development tools of the Internet of the Things, IoT development tool, IoT API development, third-party integrations, connectivity with wearables, IoT gateway development, data analysis. So here can be seen IoT application development is one of the tools. API development, today we are living in the era of API. No software, no module is have life. When someone is working, it has a certain small life. After that, new API is generated. Third-party integration, software is there. Connectivity with wearable, IoT gateway development, data analysis. Then IFTTI, if this, then that. This is one word, IFTTT. If this, then that. Most of the data development tool of the IoT, Arduino, Eclipse IoT, IBM Western IoT, IFTT, and JETA. IFTT means it is based on if this should be done. If this should be done. Help everything work better together to provide automation, such as adding Android phone to call Google spreadsheet. Spreadsheet is prepared. So whenever you have time, you can see that spreadsheet. You can watch over this one. Adding new tasks to your Amazon Alexa to do and will add IOC reminder app. If international space station passes over your home, some of the international space station passes over, then you will get a smartphone notification that you can switch off some of the sensitive devices, and that could be done by IoT. JETA, it is an open source platform built on the Node.js for creating Internet of Things server that run across geo-distributed computer. It is geo-distributed computer and cloud. So JETA is open source. So here you see most of the software in IoTs are open, and these tools are Arduino, Eclipse, IBM Western, IFTTA, and JETA. Top development tools, TESL 2. This is on board, equipped with numerous sensor and modeling, including our fit camera, GPS, and oscillator. It could be used to build basic IoT solution and prototype. Eclipse, these are the descriptions which tools we have given there. So TESL 2, this is used for board-based equipment, where board is equipped with numerous sensor modules, including our fit camera, GPS, and oscillator. It could be used to build basic IoT solutions and prototypes. Eclipse IoT is used to build IoT device on a cloud platform and gateway. Arduino is providing intelligent direct and critical infrastructure to the computer. It is a combination of software and programming language, and integrated hardware environment. IBM Western. It is an API cognitive search, content analysis engine used for messaging platform and websites, which can be understood and natural language. SCADA, supervisory control of the data acquisitions and human to machine interface that could hack. Advantech unveiled IT Gateway Smart Starter Kit. So if we are talking about IoT Gateway Starter Kit, here Microsoft Azure IoT Gateway pre-configured Windows 7, 4 GB memory, and hard disk, pre-integrated IoT software, voice, WAS, and RMM that we have discussed. It is used for data management, device monitoring control, security, software development kit. It has includes. It means that this Advantech unveiled IoT Gateway Starter Kit. This is a kit, and these are the features available in this particular kit. Software development kit, gateway, IoT developer forum, IoT news, software design tool, software update tool, technical support, 3-hour online counseling, and frequently asked questions for discussion. So these are the things that is available in the Aventech Unveiled IoT Gateway Starter Kit. IoT and web things. Here, IoT is one part where devices are connected Zigbee, Bluetooth, X10, BACnet, OSIN, and we have a website which is web of the thing, where each and every website is connected with that one. So it is connected through the web. So IoT and web both are working at parallel, one by one. And sometimes we are talking about IoT and we are using some portions of the web of the thing whenever we have. So similarly, we have a web of things, we have multimedia of things, IoT, MOT, WOT. These are the common specific names based on their content are given, and they are having greater role in today's environment when we are talking about or we are requiring data science as one of the things. Web things of applications, pillars of the web things, social web, Facebook, Twitter, and then semantic web, microdata. Then we have programming web, different kind of APIs. Then we have real-time web, WebSocket, and push notifications, webhooks, and RSS ATMs. So these are some of the pillars that we have web of the thing. But here we are not going to discuss more about web of thing because it is not concern of the today topic. IoT limitations. Now, so far we have discussed positive things of the IoT, but remember, each and every coin has two faces. One is positive, one is negative. Nothing is fully positive, nothing is fully negative. Mixture of that provides us suitability of that one. So here, it would be worthless if we do not discuss IoT limitations. As the number of connected devices increases, more and more information shared between devices, then potential hacker could steal confidential information also increase. It means that when there is more and more sharing, today, many times we got a phone that you have won this amount of lotteries, and you share your account and other details. We want to transfer this money, but remember, there are the fake header, fake one. If you share your account and other details, they might be evacate your money. Enterprise may eventually have to deal. So in the IoT, where more and more sharing is concerned, in that way, it would be more and more chances of hackers, facility for hackers to steal your information. Today, sometimes we say that Facebook has steal our data, data leakage. This is one of the problems. Facebook has sold our data, and selling the data and getting the data is a crucial matter today. Sometimes it is able to influence some of the countries' polls like that. So more and more sharing, more and more hacker probabilities is there. Enterprises may eventually have to deal with massive number of IoT devices, and collecting and managing the data from all those devices is challenging. Bug may corrupt the entire system. If a particular bug which induced in a particular IoT, as they are connected, it may corrupt the entire system. And in IoT, anytime, anywhere, anything, any device, so there is lack of international standards that may sometimes give incompatibility in the result. So these are the limitations that we have. IoT security concern. Now come to the another aspect. First part was IoT introduction, because as topic was concerned IoT and IoT security. So first portion is narrated. And then second concern is IoT security. IoT security concern, which of the following are the greatest security concerns of organizations to the IoT initiative? First one, physical unsecure endpoint. So first one, physical, when you are planning to implant IoT devices in your organization, first you are required to see physical unsecurity at endpoint. This is backed by 63%. It means that you are required to put the guards and locks and all the things. Poor authentications of IoT endpoints. It again backed by 55, just after 63. Unsecured applications secure vulnerability within IoT system. Even it is unsecure within secure vulnerability IoT system, unsecure network between IoT and endpoint and central one, 42%, unsecure IoT database or data storage, it is 27%, denial of service attacks, those who have gone through network, they might be knowing denial of service attack. It means that unnecessarily someone bagged the money. I am telling you an example for denial of service attack. Suppose I have a money, I can purchase all the things from the market and kept in my store. It means when someone goes, it says that shortage of the item. So that is kind of denial of service attack. So denial of service attack, it is a stylish attack, which is 27 other. So if you look at the IoT security concern, physical authentication, vulnerability, endpoint and network connect, and security. So at the many level storage, there we have this one. So different kind of security concern of IoT devices are there. IoT attacks. What kind of attacks we have? That is physical attack, network attack, software attack, and data attack. So in the physical attack, tempering the perception layer, sleep denial attack, and then attack, malicious code injection. Someone injected the malicious code. RF interference, jamming perceptrons layer. At the perceptrons layer, it is RF interference, fake node, injecting the fake node. Someone is injected as the fake devices, and that device resembles that I am true, but it is not true one. Sleep denial attack, side channel attack, permanent denial of service attack. We have denial of service attack, we have distributed denial of service attack, we have permanent denial of service attack, so many names is given. Then we have network attack, traffic analysis attack at the network layer, at the perceptrons layer, physical one, at the network layer, traffic analysis attack. Then we have RFID spoofing. RFID is one of the things that is used in anywhere. We put a particular chip are fed, and that we are able to detect it. Because it is small range radio frequency, unauthorized access at the layer, so spoofing is there. Routine information attack, routing information attack at network layer, selective forwarding means biasing is there. Sinkhole attack, these are another kind of attack. Wormhole attack, Sibley attack, man in middle attack, it is there. Some of these attacks we will discuss later on. Replay attack, denial, distributed denial of service attack, DOS and DDoS. And here we have PDoS. Then we have software attack, virus, worm, Trojan, horses, spyware, adware, applications layer, malware processing layer, data attack, data inconsistency, network processing layer, unauthorized access processing layer, data breaches, network layer. So these are the attacks: physical attack, network attack, software attack, and data attack. These are the some of the attacks we have named it. It is not possible to go through all these ones. So let us see how illicit IoT security market. So this market we have, because market is related with the job. So here we have a application, cloud, endpoint, network, and other. So these data we have given is starting from 2015 to 2025. So security market of the US IoT, and this data which is shown here is $1 million for US. It is US data only. So in the US, applications, cloud, endpoint, network, and other one. So here if you see, endpoint user is getting more popularity. Network is also, but among this one, endpoint is getting more and more popularity. So there is IoT security market is there. Security continues to concern of IoT developers. They try to what? What are your top two concerns for development of IoT solution? So top concern of the IoT developer, these are 2 years data in 2018 and 2019. Security concerns in the 2018, it was 30%, and 2019, it was 38%. Connectivity security concerns, 16 and 21. Data collections and analysis concern, security there, 19 and 19. Performance security, 11 and 12. Privacy, 11 and 8. Integration with hardware, while you are integrating with hardware, or a security concern, 16%, 18%. Standard, 11 and 16. Return on investment, if you are dealing that particular application, security concern is 14 and 15. These are the answer of this question. What are your top two concerns for developing? So based on this one, if we pick up the top one, so security and connectivity. Security connectivity is top one. IoT ransom malware attack. This is one kind of attack. Everybody is familiar. Ransomware attack. Predicted damage cost. Here, in the IoT, if the attack is there, though it is a small amount, but its effect would be very, very large. Its effect would be very, very large. So if you go ahead with this effect, you see 2015, it is reported in billions US dollar. In 2013, 21, it could be around more than 200 billions US dollar. Ransom cost tag more than $2 billion. Ransom malware attack, here we try to see this attack as step by step and try to understand how this ransom malware attack performs. First step, victim receives malicious information. So first instance, just like I was talking that sometime we got a very good message that we have won this particular thing. So victim receives malicious information, maybe any information. Then second step, when victimized email browse malicious download. As soon as victim or victimized or email, जो भी है, it download that malicious code. It moves to third step. File is victim computer are encrypted. The files of the victim computers are encrypted. Then ransom message is displayed. When third phase is completed, the message is displayed and payment is demanded. So purpose of this ransom malware attack may be financial, extortion of money. If it is extortion of money, it demands the money. Some cases we will discuss later how different applications ransomware is used. Then we have fifth step, victim used to browse to pay the money in digital currency. Here, victim has to pay the money. Suppose your file is locked, your computer is locked, and someone is demanding that you give 100 rupees, pay online, I will unlock your computer. So if you have some of the work, it would be better you pay. If it is a small amount, everyone is paid. In that case, it is a huge amount. बूंद से घड़ा भरता है. So these 5 steps. Step 1, victim receives malicious information. Second step is process. Victim open the mail. Then 5, once you have opened the mail, it means that you do not have a control. So it will automatically go to third step, automatically go to the fourth step, and go to the fifth step and demand the money. If you pay the money, you may be given intermediate release. Sometimes malware attack, again same things. Victim receive malicious download. Victim open the malicious download. When you are downloading, malicious download is there. Victim computer is locked. Ransom message is displayed on payment of demanding. Victim use browser to pay the money in digital currency. Hacking, IoT hacking. Distributor denial of service from hacked IoT devices. Attack vector, compromise control server, man in middle attack. It hacks some of the services and compel the server to go in compromise control mode man-in-middle attack. This is another one. Corrupt the firmware with hacked update. Some update is there. Hack through default password. Some password is hacked. Embedded malware via telnet. Hack device through JTAG and open port. So attacker vector, insecure communication, vulnerable firmware, poor authentications, compromised OS and tool, secure chipset. These are the IoT part. So attacker vector is there. Compromise control server, middleman attack, corrupt firmware which hack, update, hack through default password, embed hardware, and then as a part of attack, launch denied of service attack, send data to unauthorized control server, means pick up your data and send to the unauthorized control server, infect other IoT devices. These are the attacks. So a distributor denied of service attack from hacked IoT devices are three attacks. Launch distributor denied of service attack to the IoT, send data to unauthorized control server, infect other IoT devices. IoT hacking vulnerability. Here we are discussing some of the IoT hacking cases related to the vulnerabilities. Look at first case, Mirai botnet attack, Akadine attack, which took place in 2016. It was a distributed denial of service attack. It uses the IoT botnet possible by malware called Mirai, focused with the DVR player. It is focused to the DVR player and digital camera. So in 2016, distributed kind of denial service attack was used. Possible malware Mirai focus, and its focus was DVR and digital camera. This lead to huge portions of internet going down, including Twitter's, The Guardian's Mail, Netflix, Reddit, and CNN. It means that huge amount of internet is down, distributed denied of service attack. They are demanding the money for opening this, releasing this one. Another kind of hacker cardiac devices. One of the famous hospitals, St. Jude in USA, this attack, hackers came, it was equipped with IoT devices, and it is again related to 2016 case. St. Jude Medical, it is a specific hospital that is used for implantable cardiac devices, have a vulnerability that could allow remote hacker to access device. Once remote access, hacker is able to access the device, it may access pacemaker, defibrillator. If it hacks the pacemaker, it may increase the speed of the pacemaker so that heart can be disturbed. If it has defibrillator, it means that it can control about the secretion of particular medicine, which is done by IoT device to deplete the battery. It hack to deplete the battery and administer control pacing and shocks. So via these one, so once it hacks, it could be able to give huge amount of loss because no penalty is more than life penalty. So here is a life danger. Another case, again in 2016, OVA Wi-Fi baby heart monitoring. There is baby section heart monitoring, Wi-Fi baby heart devices, alerting parents when their baby experience heart trouble. Can be dangerous, can turn dangerous if taken advantage by sinister part. In 2012, TrendNet transmitted user login credential to in clear, readable text over the internet. Your login and your password is sent over the internet. It's mobile app for camera stored consumer. Login information is clear, readable text on their mobile. It means that it is open, anybody can access. Another case, hacking. It is reported in 2015. The IBM Security Intelligence website reported a particular Jeep is hacked. Once, as you know, we have one of the applications of the IoT is fleet monitoring and traffic management. So if we relate this one, a particular vehicle, say the Jeep is hacked by someone else, and who has the control over this one? In automatic vehicle, driver, there is no driver, controller is the driver. If that is the one, it means that that could hack the Jeep, and you vehicle can go anywhere as it requires. It may get accident, it may go in the valley like that. So hacking the Jeep in another case 2015. So 2016, 2012, and 2015, the cases is reported for high IoT hacking and vulnerability. Go ahead. Social engineering of attacker life cycle. How the attacker attack life cycle. Preparing the ground for attack. जैसे कहते हैं रेकी कर रहा. Identifying the victim means go ahead and analysis the victim. Gathering background information, selecting attack method. This part is investigation. Another part is hook. Deceiving the victim to gain the hook hold, engaging the target, spinning a story, taking control of interaction. This part is hook. Then we play, obtaining the information over a period of time, expanding footprint, execute and disrupt, and then exit cleverly. After doing investigation, hook and play, three activities, the hacker, social engineering attacker is very smart. It's closing the interactions without arousing any suspicions, remove all the traces of the malware that cover the track, bringing the charges, bringing the credit to the natural end, and say that it will naturally end. It means that this is the social engineering attacker life cycle as a core part, investigations, hook, play, and exit. Top IoT security risk, lack of compliance on the part of IoT manufacturer. IoT security risks are there due to the lack of compliance, international standard compliance on the part of the IoT manufacturer, lack of user knowledge and awareness, novice user knowledge and awareness is there. That's why in government of India has launched well before 2002 Information Security Education and Awareness Program across IITs and NITs and some reputed institutes, and that for information security awareness. Anytime aware, anytime we have a message from the bank that don't share your code, don't share your credential to anyone. If someone is asking the money, someone is asking your information, don't share, come to the bank, like that. So lack of user knowledge, but user knowledge and awareness, due to the lack of that one, IoT security risk is there. IoT security problem in device update, because device update, software updations management is also a problem. Lack of physical hardening. One of the major issues of this security is lack of physical hardening, because your device could not be physically, suppose it is a vehicle, it could not be at one place, so it could be not physically hardened. Botnet attack is another kind of problem. Industrial sponges, eavesdropping is another kind of problem. Hacking the IoT devices is another kind of problem. So these are the some of the top security risks in this one. IoT security issues, as we know, in the IoT security, data confidentiality, insufficient authentications, authorizations, insecure interactions, lack of transport encryptions, confidentiality preserving access control. Then we have a privacy, data protection, information, security risk management, privacy by design, privacy by default, data protections legislation, traceability, profiling, unlawful processing. Then we have a trust. So if you look at this identity management, insecure software and firmware, ensuring security, ensuring continuity and availability, realizing the malicious attack against IoT, loss of user control, difficult in making the decision. So if you look at these ones, data confidentiality, integrity, trust and privacy, they were having some common portions. So if all these three is common, it means that is IoT security covering all three one. Issues in the IoT security, ransomware attack, insufficient testing and lack of update. This is another issue, because IoT driven financial crime, money extortions, remote smart vehicle access, robo and counterfeit IoT devices, lack of users awareness regarding security, IoT security. Here, security issues and challenges. Security challenges are there. Weak authentication is one of the security challenges, data security and privacy. They are concerned with the different networks, insufficient testing for IoT devices is again one of the challenge. Weak default password is weak. Sometimes we are asked to use strong password, rise the bottleneck, aiming cryptocurrency, AI-based tool for autonomous system. This is another challenge. Unreadable threat detection, malware ransom is another challenge. Vulnerability related both physical and digital environment is another challenge. Limited capability storage, processing and memory transfer another one. Data integrity and interoperability is another challenge. Geofencing, containing enterprises is another challenge. So again, we say open security, insufficient insecure web services, insufficient authentications, insecure services, privacy concern, insecure cloud interface, insecure mobile interface, insufficient, insecure software, and poor physical security. These are and the security challenges for IoT devices. Security concern to the IoT, confidentiality, integrity, authenticity, authorizations, non-reproduction, availability, privacy. These are the well-known terms used in the security concerns of anyone here. Again, confidentiality, integrity, authentications, authorizations, and non-reproduction, availability, privacy. These are also concerned here. And we have simply defined them. Privacy concern of the IoT, protecting consumer privacy become increasingly difficult. How the privacy of IoT device is concerned, difficult to control data on diversified devices, remotely connected and detected and can hide the enormous amount of physical data. Control can be lost more and more complete data about the user. A particular law professor epic, I observed that IoT will result word in more prison life. IoT will result in a world that is more prison-like with a small class of watchers and much larger class of experimenters on the watched. So these are some of privacy concerns. Way to solve the vulnerability and device protection, authentications of IoT devices, change the password often and make them strong. Don't rely on cloud technology. Avoid universal plug and play system. Don't use your system anywhere else. Use secondary network for IoT devices that could help you to prevent unauthorized access to your private file. Stop any attempt of hijacking IoT unit and implementing malware, completely placing the IoT device beyond the reach of any outside. Update patches of your IoT device regularly. So these are the way vulnerability and device could be protected. Authentication of the IoT devices, change password often and make them strong. Don't rely on cloud technology, avoid universally plug. Don't use your device here and there without thinking, without planning. Use secondary network for IoT devices so that you can save some of the credential. Update patches of your IoT devices. Attack on authentication, impersonation, man-in-middle attack, denied of service attack. These are well known. These are again man-in-denial of service attack. These are the keywords. We have already discussed these one. So again we have, so attack authentication process, attack on authentication. Here it is an example. Suppose this two men, they are communicating with the API, MU1 and MU2, and the intruder came. Now this here in B part, it would be say that intruder try to say that I am MUN. So this is kind of attack. Man in middle attack, everybody knows. attack on denial of service attack on authentications. Hacker control the server and data server reply, don't reply, don't reply. So it hacked all the server and victim get the, so DNS request with IP proof source, DNS query get all the recorded website and victim data is forging reply attack. This is another kind of attack, sniffing. Attacker get the control and it says that attacker is communicating. Forging sibling attack here in the IoT, many times it tried to have a topology. So in the sibling node, victim node try to create same topology as it could be in there, so that system, IoT system does not able to have the kind of discourage that it is unknown one. So it try to create the topology based on that one. This is another sibling attack. FI to secure IoT devices, install reputable internet security software on your computer, use strong and unique keyword, be aware of some apps and go through privacy policies, do your research what type of data device you collect, know data device and app you want to access on your phone, avoid unnecessary app, use trusted VPN, check the device manufacturer website regularly, use caution when social sharing features with these apps, never leave your smartphone unattended if you are in public place. Effort to secure the devices, these are another one. E2 is security, domain security identity management. IoT security and cyber crime. So these are again smart, as we have already discussed these one. Way to protect against cyber crime, keep software updated, operating system updated, antivirus software kept on updated, use strong password, never open attach of spam mail, do not click on link of the spam mail on untrusted website, do not give your personal information unless secure, contact companies directly without asking. Security to curb, these are some of the examples. Cyber criminal take advantage of security oversight, grab the confidential information of cloud security. Criminal can invest in secure wireless connections upon authorized devices, grabbing the door and all these things. These are some of the examples. And these are some of the references from where we have taken these matters. Thank you. So first of all, I thanks for your patience. अब कितने लोग सुन रहे थे, कितने लोग नहीं सुन रहे थे, ये बहुत बड़ा मुद्दा है ऑनलाइन में। दिख तो मुझे रहे थे 120 के लगभग, but again I thanks for your patience of hearing. Anything, if you have any questions, I am ready to answer.
Participants, you can answer your queries or questions.
Good morning, sir.
Good morning.
First of all, I want to say thanks for sharing a very nice information. Sir, my question is, what is one policy change that would accelerate the benefit of the Internet of Things?
Policy, actually, sometimes government is making the policy because in the IoT things and other security concern is that in the IoT, you do not have a common platform, right? Each vendor, each manufacturer, each one is making its device, giving the software, giving the hardware, giving the users different kind of cheaper things, not genuine things. They are in the market. So that's why there is a compatibility issues, right? So government sometimes is making it standardized, but it is not possible. So more or less for the IoT security, we should be aware, nothing else.
Okay, okay. Thank you, sir. Thank you.
Sir, one of the participant is asking what are the possible attacks on IoT devices?
And that I have shown. Possible attack on IoT devices that I have shown many times.
Participants, any other queries?
Yeah, ma'am. Good morning, sir. A very commendable presentation from your side. Let me congratulate you for that. I would like to know what were the possible solutions wherein a business ethics can be insulated from this kind of cyber attacks. Can you please provide one exemplary illustration?
Just if you look at my slide, where
Yes.
we have discussed many times, and if you are using internet, you are using your personal bank, mobile bank, it try to say that use a strong password, right?
Yes, sir.
And don't share your information to anyone. Many times from the bank, for their persons, cyber criminal ask that I am from the bank, I want to update your PAN card, I want to update your ATM card, and I require your credential.
Okay.
Okay?
Yes, sir.
In that case, if you share your information, then it would be dangerous. Many times bank says that bank never ask this one, bank never ask this thing, but many times you just, I am telling you an example. One person called me over my phone just yesterday, and he was asking that you have done a LIC of 50,000 per year for 5 years, 7 years, and it was insured for 10 years. But I don't remember. But he was constantly telling that this is this, this is this, this is this. But to the best of my knowledge, I have not done such. So if I share my credential, बैंक account और तमाम चीजें जो है ना,
Yes, sir.
then that fellow it is efficient sufficient for them. अगर किसी को आपका आधार पैन और एक पासवर्ड पता चल जाए,
Yes.
so he can explore anything about you.
Yes, sir.
So in the IoT security, best part is that you don't share your information. जैसे आप बैंक में देते हैं, मतलब जैसे अभी 2016 में जब पैसे बंद हुए थे 500,000 की नोट, तो बैंक वाज गिविंग द मनी 3,000 टू ईच वन. और उसके बाद क्या किया कि जैसे ऑनरेबल सुप्रीम कोर्ट का भी है कि आप जब बैंक में कोई इंफॉर्मेशन कहीं किसी को देते हैं प्रिंट आउट, तो उसको क्रॉस करिए, उस पर साइन पर्पस लिखिए, सो दैट इट कुड नॉट बी यूज. बट मेजॉरिटी जो है प्रिंट आउट लेकर के सीधे दे देता है. अब मैं उसको जिराक्स करके और 500 बना लूं, आई कैन शेयर इट, दैट काइंड ऑफ थिंग्स. तो जो भी रेगुलेशंस है, जो रूल्स है, जो उसको पढ़ें और उसको यूज करें. अवेयरनेस से ज़्यादा हो सकता है, बिकॉज IoT इज बहुत मतलब अलग अलग स्टैंडर्ड पे है ना. This is what I think. So I think you have gone through much of the time, 2 hours. अगर सुन रहे होंगे तो ठीक है, नहीं सुन रहे होंगे तब भी लॉगिन तो है ही हैं.
Thank you, sir.
ठीक है.
Thank you, sir.
Thank you, sir. Thank you. Very informative sessions.
Okay. So may I leave?
Yes, sir. Yes, sir.
Ma'am, you're not audible. Please unmute yourself.
Welcome to all the participants. Now we would be going ahead with the second session. I would like to invite our next speaker, Professor Jamuna Kant Singh. Currently, he is professor in Jadavpur University. He has done his MTech from IIT Kharagpur and PhD from Jadavpur University, Kolkata. He has got several publications in international journal and various conferences which has been held national and international level. He has supervised many theses for masters and several theses for PhD over the years. His specialization area includes face recognition, medical image processing, computational intelligence. I would now request Sir to start the session.
Okay, thank you for introducing me. And I feel that I'm privileged to give you some talk in this FDP program. And thank you for inviting Professor Salma for inviting me to deliver the lecture. And welcome participants. Before I start giving my talk on the subject, can I give some information about the participants so that I can arrange my talk accordingly? How far, how deep I can go and like that. So Professor Sharma, you can give some information about the participants, in which background or maybe whether they are working professional, working teachers or in institute or university, something like that. Just a basic background.
So we have faculties from all over India. We have IT professionals also. So basically we have people, academicians from everywhere.
And they all are from computer science department, electronics, electrical, or something like that also there in the participant.
Yeah, basically from different fields. Some of them from computer science, some of them from electronics department also.
Okay. Fine. So shall I start?
Yes, sir. Sure, sir.
So let me share the screen.
So some are from energy economics background also.
Okay. So can you see my slide?
Yes, sir, it's visible.
Okay. Hello, participants. This is Professor Jamuna Kanta Singh from Department of Computer Science and Engineering, Jadavpur University. And this is my email address. If you record in future, you can contact me, right? So as I got information from this FDP, that is actually that based on the data science. So I feel that why not I give a talk on neural networks. That is part of the machine learning and very much required for analysis of data, whether in the form of raw data, in the form of image, or maybe any derived data. So I prepare this one, right? So how many of you studied the neural networks? Any idea? So accordingly, I can arrange my talk. Have you studied neural networks in or have you did you teach in your institute, or have you worked on for your research purpose in neural network? Anything? Any idea? Anybody can reply?
Sir, basically we have faculties from every level. Some of them
Mhm.
have the knowledge at the basic level, while some of them have done the research work to at a larger extent also.
Okay,
So
fine.
it's a like a mixed batch.
Okay, okay, fine. So what I will try to give you that some basic fundamental concepts, right? In I have seen that many cases, if you use some package, something like MATLAB or Python or whatever it may be, usually people do not write program. They usually use tools for neural networks, maybe multi-layer perceptron or maybe SVM or whatever you can say that is whatever the new neural networks coming on. So usually people tend to use the software or packages in the form of functions, and they provide the data in the form of files or whatever it may be, and they get the result. Right? So this is something like a black box tool. You don't have to go into the, or you don't have to understand the details inside the neural networks, how it works. Right? So my concept, my thinking is something different. My thinking is that you should know the details of inside of any package or the software, whatever you function that you use to in MATLAB or in Python, whatever. So you should know the knowledge about the detailed function of those functions, how they work, right? So I try to give those in the short period of time in the basic concept, how things are working inside the the neural network, something like that. So let us proceed. So is it not visible now that the
Yes,
heading?
they are changing.
Is it visible that
Yes, sir, they are visible.
okay? Because from my screen that heading is not visible. Anyway, so what is the machine learning? People used to say that I work in machine learning, or I am interested in machine learning. So what is actually the machine learning? So as it is written, the field of study that gives computers the capability to learn. So you are giving some sort of the information so that the computer can able to learn, like we do by reading something or by seeing something, we are able to learn, and then generalized without being explicitly programmed or human assistance. So by learning something, but in other words, by acquiring knowledge, you can apply those knowledge for an unknown situation to get desirable result. So this is known as the generalized, right? So machine learning, it deals with studies of different techniques, obviously the algorithms and the design of those, and that helps a computer to learn, and then whenever required, it recalls those information, and then it produces the generalized or produce the success, the desirable result. So that is called the generalization of the computer. Now, question that arises: how does a computer learn? Does it has a brain like we human being? Whether really the computer able to learn, and if it is able to learn, does it has a brain like the human being? So it actually don't have the actually straightforward answer. It has even so many steps. But in the second question, we don't have an actually brain. So what you have to do is you have to design a model. You have to design a model so that using the algorithm and the model, you can able to make the computer to learn, right? And whenever that the situation comes, make the computer to apply those knowledge so that it can produce the desirable result. So like that, I've given that 3 points. To behave like a human being, a computer has to go through a process that is called the learning or training. How? So how the training process or the learning process goes? So it using the labeled or unlabeled known examples. So we need some known examples, right? So I will come later on that what are those labeled and unlabeled examples or samples or the patterns or items, right? And then second thing is that, so in order to make a computer system learn, you need some label or unlabeled known examples. This is one thing. Second thing is that for each distinct problem, you don't have to generalize. For each distinct problem, let's say the one problem is you're recognizing characters, right? If the English character A, B, C, D like that. Another thing is the recognizing the numerical digits 1, 2, 3 up to 9 and then 0, right? So these two things are different. If you design a neural network that will that can able to recognize the English alphabet, cannot be used in the same way, right, as it is applied in the alphabet. It cannot be used in the for recognizing the digits. So these two problems are different domain. So we have to, that's why I have written for each distinct problem, this learning or training process has to be performed before the computer, let the computer to predict the unknown samples. So these two things are different. So what I am trying to give you the idea is that for each distinct problem, you have to design a neural network or the model. And for that problem, you have to collect the label or unlabeled samples, known sample, and then using those samples, you have to train the network, right? So this is the second point you have to keep in mind. And then through the learning process, what the computer does is it acquires knowledge from the known samples that you have collected earlier. So from the known samples, by feeding them into the model, the computer will be able to acquire knowledge from the known samples. And then whenever required, these knowledge are recalls, right? And then produce the desirable result. So these are the 3 points that you have to keep in mind while dealing with neural networks, something like that. Right? So let's go here again. Now the computer needs some free parameter. How the knowledge are stored? How the computers or models are storing knowledge? So in that purpose, it needs some free parameters for storing those knowledge. Are they in the form of these parameters, maybe in the form of weight vector or prototypes, or maybe any other forms? Now, another thing that nowadays we'll find that machine learning is a new things. People are crazy about this. So is it a new paradigm? Answer is no. It is a part of the artificial intelligence, which is the vast subject, vast content. So a part of the artificial intelligence is nowadays is known as the machine learning. You have to make a machine to learn from the examples of past experience, and let the experience is recalled by your computer to produce the reasonable result. So, audience, if you if you have any doubt in the between, you are free to interrupt me. I will be happy to answer you. Right. So whatever it is, just I'm not the general. This is, don't treat this lecture as a general talk. Try to give or try to get some idea how things are going on inside in a neural network, how to design, right? So how the information going from one point to another point, and then how to actually train the neural network. I will cover those things. So that's why I'm asking you that please don't take it as a general talk that you listen and forget. Try to get some information so that you can able to get some idea that, okay, how the neural network works inside the model, right? So that's why I ask you that if you feel any, if you have any doubt, so please free to interrupt me. I will be happy to answer you. So let us move on. Now, as I told you that I will cover the artificial neural network. What the artificial neural networks actually means. As it says, the artificial neural network tries to mimic or implement the function of human neural systems. So you know how our nervous system or neural system works, right? If you have any stimulation in our body, how it goes to our brain, right? And brain takes the decision to respond. So something like that, it is artificially tried to implement our nervous system, a neural system, how signal passes from one part of our body to our brain, and brain takes the decision. So how actually? This is not like that it is automatically goes, right? There is nothing automatic. Everything is driven by some function or the signals. Now, why the peoples are interested in artificial neural network, or why the people, researcher in the earlier in the 90s, they try to implement the human nervous system, because it is a complex, non-linear, and parallel information processing system. So this is important, third one, right? So as of now, today also we are actually in some situation, we are many times faster than the conventional computers for getting some information from the input data, right? So that's why the people are trying to artificially implement the functions of human neural systems. Like an example, I am giving this one example. Let's say that our human vision that we see through our eyes, actually this is an information processing task. Through our eyes, we actually get some information from our environment that we see, and getting those information inside our brain, it computes so many things, right? So how actually the things are going on, we don't know, but it processes something that we see from our environment, and then it provides a representation of the environment around us. Let's say you have taken blindfolded to a new area, a new place, and then you are left there. So if you see your environment around you, you can able to actually to identify, or maybe able to understand the situation around you, that where actually you are, what is the situation, is there any danger about you, right? So that provides you a representation of the environment, right? And then whenever the unwanted situation arises around you or on you, you can able to interact, or you can able to take a decision so that you don't harm yourself, right? So these are that is actually you got the knowledge from by seeing the environment through your eyes. You got the knowledge that you use those input, this knowledge is stored in your brain, and then when unwanted situation comes, arises, you will to escape from that situation. So you will to apply those knowledge, and you can able to escape from that situation, unwanted situation, right? So by definition, what the neural network, as it written, massively parallel distributed processor made of simple processing units, something like that. We have our neurons. Here also simple processing units. They are connected in chain-like fashion, and they are parallelly, they are connected, and they have the natural tendency for storing knowledge and making them available whenever necessary. So something that we do in our daily life, something like that. Now the knowledge, now as I said, the neurons are connected, interconnected parallelly. So the connection links, they have something like the weights that we have seen out the weighted graph, right? In the weighted graph, we do give some weight to the links. So these weights are known as the, in this case, it is the synaptic weights or connection weights. These weights actually used to store those knowledge, acquired knowledge. So I'll give you those examples, how the synaptic weights are, right? And how they are storing the knowledge from the examples. So before going to in details, let us recall our biological neurons. As you know, that it has 3 parts. One is the dendrites. This is the, let's say, sorry. Excuse me. Let me set up this. So dendrites, these are the actually dendrites. These are the threads like, these are the dendrites, right? You know, actually from your, maybe in the class 10, we all you have studied. So these are the dendrites through which the information, the signal comes, right? And then body, cell body. So this is the cell body, and this is the axon. This part is the axon. So it has the 3 parts: dendrites, cell body that computes something, and then computed information that goes to next level of neurons through axon, right? So information passes from left to right. So so this is the biological neurons. Now get this one. This is actually the artificial model of the biological neuron. Similar to the previous one, these are okay, fine. So these are actually dendrites, and this summation, this symbol is the cell body, and this arrow is the axon, similar to the biological neuron. Now, how it computes in artificially? It multiplied with the signal. Let's say the signal is x1, x2 up to xm. So this signal is m elements. So m, the signal vector is dimension is m. So it has the m elements or m features. For each feature, the one dendrite. So, and with this link, we have the synaptic weights. So these are known as the W, K1, K2 up to Km. M is the number of features. So number of features that goes to the cell body. So for each feature, we have one link. Now how it computes, and then B, this is the bias. It is always, there is some bias, right? It is human being, there is always a bias You can ignore some information based on your perception, something like that. So it has another signal that is known as the bias signal, BK, right? And for each link, we have the weight, synaptic weight. Now, how the information goes from the signal to the cell body? So it multiplied with the weight, xi into wki. So x1 into wk1. So write that. And then get summed up plus the bias, and then it goes to the that give you the vk, and then this vk, this output of this neuron, that goes through activation function. Activation function means that whether you proceed the computed signal to the next level or you can ignore. That means you make it 0, right? So like you do in our human nervous system, that some information maybe we ignore, some information may be forwarded to the next level. So like that. Now the activation function, this is something like the threshold. If the vk, if it is greater than 0, make it 1. That proceed to the next level. If it is negative value, you just forget. So you just ignore. So make it 0. Piecewise linear, that is if vk is greater than or equal to 0.5, make it 1. If in between 0.5 and minus 0.5, make it as it is, right? And if it is minus 0.5, you make it 0. Something like that, that graph. Also the sigmoid function, you can have a S-type, the activation function, that is the sigmoid function, something like that. Anything, audience, any question up to this? So we will be happy to answer you. Okay, if you don't have question, let us proceed. I'm trying to give you some basic idea, not in advanced research-oriented idea or something like that. I want to give you the fundamentals, right? I feel that okay, if your fundamental is clear, you'll be able to design, or you will understand any type of neural network, how they work inside the model, right? So that's why I prefer this one. Then single types of neural network, maybe single layer feed-forward neural network. Single layer means you have only output layer and the input layer. And feed-forward means the information passes from one side, one direction to other direction, from left to right. Now question is there, how many neurons you have in the input layer? How many neurons you have in the new input layer? And how many neurons you have in the output layer? How to design, how to identify the value of small m and value of capital C, that is in output layer. Any idea you have? Those who are working in neural network?
Sir, I think that the features which we want to make the neural network learn, that many features we have to supply in the input layer, and the outcome will depend that whatever like we want to get in the output. For example, if we are working in a classification problem, then the output might be yes or no. So the output layer can have one node, and input will be consisting of the information which we want to, or the features which we want to pass to that neural network. But I guess
Yeah.
might be the.
Okay, you are right. So I just want to, try to give you some more explanation. The input layer, that number of neurons, as I written here, they are small m, x1, x2 to xm. So it actually depends on the feature vector, size of the feature vector. That means how many features you have in the input signal. If you are talking about the 2D signal, so x1, x and y, so it should be 2 neurons. If you are talking about the features of the 3-dimensional space, so 3 features, it should be x1, x2, x and x3. So it depends on the size of the feature vector, dimension of the feature vector, how many features you have in each feature vector, right? So it depends on the derived feature that you can derive from the data, or sometimes you have already the number of features is given, something like that. If you talk about the iris data, have you heard about the iris data? Iris flower, that is well-known data for the machine learning domain. Iris flower.
No, sir.
So you can search in the website the iris flower data. So that is easily available. There are actually three different types of flower. Each flower has the 50 samples. So total is 150, and each sample is has 4 features. So, like that. So you can get it from the machine learning repository website that is freely available. Anyway, and whatever the output layer, as she said, it actually depends on the number of samples, number of different samples, or the actual number of different class or objects in your problem. Let's say if you are talking about the recognition of numerical digits. So how many digits we have? 10. 1 to 9 plus 0. So 10. So the capital C, its value is 10. So 10 number of neurons you should have in the output layer. If you are talking about the alphabet recognition, so that is 26, right? So like that. But if you have only 2 samples, or sorry, 2 classes, x1 and x2, or let's say true and false. So in that case, 1 is sufficient, right? If you have the more than 2, 3, 4, 5 upwards, so those number of neurons you should have in the output layer, right? And this is the fully connected feed-forward neural network. Fully connected means any neurons in the left-hand side, lower layer, that should be connected to the each neurons in the upper layer. Now see here, X1 is connected to all the neurons in the output layer. So this type of neuron is known as the feed-forward, the fully feed-forward, fully connected neural networks. Now, in summary, it can be written, or it can be represented in the form of the right-hand side, that box, in the form of box. But why it is known as, although you have the 2 layers, input layer and output layer, why it is known as the single layer? Because the input layer, it does not compute anything inside the cell body. It actually just passes the information to the next level. So it does not involve any computation within the cell body. So that's why this input layer usually in this case is ignored. So that's why it is known as the single layer feed-forward neural networks. Right? Now come to some complex neural network. This is known as multi-layer, more than 1 layer. So we have the input layer, that is compulsory, output layer, that is also a single output layer, and in between input layer and output layer, you can have 1 or more than 1 hidden layers. Depending on your design or requirement or the problem, you can have different more than 1 hidden layer also, right? So 1 or more hidden layers that extract higher order of statistics depend on your type of neural network. And layers are fully connected. As I said, a neuron in the lower level layer, that is connected to all the neurons in the higher level of the neuron. So now let us some basic concept why and the question. So what actually the artificial neural networks does? We have studied the structure, right? The types of neurons and the output neurons. What actually the neural network does? Now, as I said that In almost all the cases, it classifies the unknown samples of patterns based on their features or feature vector, and then recognizes. In most of the cases, it is for the classification. Artificial neural network is usually used for the classification. You have a number of samples of different classes or objects, or classes, or the clusters, and then you try to classify them. You try to group them, right? Based on the unknown, based on the known sample, and then you try to recognize them. What is that actually? So this is similar to human cognition process. Everything, whatever we see, we try to recognize or classify. If you see a new car, let's say you are moving through a street or maybe through a city, and you have seen a new car just passing by you. So you try to understand that what is the car actually, new car. You have not seen before. So what you are actually trying to classify the car according to your known car, and then try to, once it is classified, whether that is the Maruti or maybe Hyundai or maybe Honda or something like that, and then try to recognize the car, right? So similar to human cognition process that we do in our brain daily life. So in most of the cases, artificial neural does actually same thing. Now designing a neural network. So how do you design? What are the requirements? As I said, a set of known or unknown samples you require from the multiple classes or the multiple clusters, right? You have to collect a number of known or unknown samples from the multiple classes, not a single class, right? Multiple classes, more than two, or maybe two, more than one actually. And for each class, it should have multiple instances, right? Having more than one samples per class. So these are the requirements for designing a artificial neural network. Not like that you got one sample per class. So that is not sufficient for designing, for using a neural network. You have to collect more samples per class, right? So this is the requirement. Any question up to this? We can, otherwise I can proceed further.
Sir, I want to ask one question. Can I?
Yes, fine. Yes.
Sir, as it is written that a set of known or unknown samples of multiple classes. So, what I mean to say that is this we should not know the result of classification. The meaning of unknown is what is the meaning of sir unknown? I'm not able to.
Unknown actually sometimes some neural network uses for unsupervised learning. Right? I will give you one example that basic neural network where you don't have to provide the actual class of the samples in which they belong.
So the class
right?
is not known.
Now,
so,
okay.
Sir, if
yes.
the class is not known, then how we are going to have the output output nodes? How we are going to have?
Yeah, I will cover that. I will cover that thing. Okay.
Fine.
Something like that. Something like that. You trying to learn how to drive a car yourself without going to a driving training institute. You bought a car and you move into a big field, right? Empty field, and you try to learn yourself how to drive, right? So that can be done.
Okay.
Right?
Okay.
So I will cover that thing also, that how from unknown samples where you don't provide any class information that in which they belong, right? So how the neural network will be able to learn from those unknown samples. It can be possible, right? Not all the cases you have the known sample. You may sometimes you have to use using the unknown sample, completely unknown sample, right? So I will cover the basic thing. Any questions, participants?
I have a question. Shall I?
Yes. Yes.
Sir, as you said that multiple classes of cluster required. So why multiple classes? Why not?
If you have the single class, so there is no need for classification. They all belongs to the same class, right? That you got a number of samples. Let's say all samples. Let's say you got 10 samples of 5 that integer, right? Let's say you are recognizing the integer. The digits 1 to 9 and 0, 10 digits, right? And you got a sample, 10 samples. All samples are of, let's say, 5 digits. That represents the 5 digit. So I don't think that any you require for classification, because they all belongs to the same class, right? Although you do the classification, but that eventually you will get all samples, 10 samples that belong to the same class, which is 5.
Yes, sir. Thank you.
Is it clear? So that's why I in the previous slide I said that you must have at least 2 classes, because you are classifying. You are actually grouping those classes. Which sample goes to in which group? If your group is same, the one group, so there is no need to group them again, because they belongs to the same class, right? But one thing is that in our whatever you see in the, let's say, like the face recognition, you are identifying different person. One person is treated as a one class, right? Identifying the digits, identifying the characters, or maybe words, something like that. Also, sometimes in medical imaging, like identifying some pixels, voxels, or in the case of brain MR image, which I actually worked very much on that area. Brain MR image, segmentation of brain MR image, like that. So where you have to identify the voxel in which they belong. So like that. Let us anything you have, any question up to this? Okay, fine. Let's move on.
Set an example of face recognition and the example of digits recognition is all lying on the known sample, I think. And
all lying in the
known samples, because we need to give the neural network that this is the class where we known classes are there, I think. In the face recognition also, output is known to us that either that the face should fall in this category or that category. The number of the categories are fixed, I think. Sir, is this the case in the face?
Okay, let me answer. In the case of face recognition, or maybe digit recognition or alphabet recognition, like that, right? So if you use the neural network, I have so many works on that. If you use the neural network, what you have to do is you have to collect the instances of the persons, okay? Different faces of different person, and from there you have to divide the, let's say you have got the database of face, right? And from the database you have to divide the database, whole samples of the database into 2 sets. One is training set, another is test set, which is sometimes known as the probe set, right?
Yes, sir.
So using the training set, you model and train the neural network, which is known, and the test set, which actually known to you, but assume that it is unknown, right?
Yes,
and assuming this is unknown, give it to your trained neural network and let it recognize the person, and it will give you some result, any identity, and then compare with that which is known for the training set. You compare whether your neural network is successfully recognized or not, like that.
Yes.
And then based on that recognition or not recognition, you find the recognition rate or success rate.
Yes, sir. So in the training set itself, it is defining the output. That's why the neural network is learning the things.
That
these
is
are
the
the
known
classes
sample.
where I need to. Yes, sir. That's a known
That
sample.
is known sample. I'll give you
Thanks.
example. Okay.
Yes, sir. Thank you, sir.
And the test set is assuming as an unknown sample.
Yes.
So I'll give you example.
Thank you, sir.
Let's say this is actually, so carefully see this one. Given a set of n label examples or known examples, sometimes it is known as the people say, or sometimes you find in the literature labels examples, or these are actually known samples or known examples or patterns or items. What is that? A number of n level samples. Let's say set is capital X, X1, this is the one sample, and D1 actually the class level information, right? So this is labeled or known samples, total capital N, and of each Xi, it has m number of features. So for Xi, Xi1, I2 up to Xin, right? And Xi, X values, they are written as bold letter. Bold means these are the vectors, right? And D, the class value you have for all the samples, we have the D value, Di, and Di actually C1 to CC, capital C. So capital C number of classes. So in other words, you can say the n number of level samples, they belong to capital C number of classes, which is given in the set. This is known actually training set, right? If D is not present or not used, although you have, but you are not using, you are hiding this D information from the neural network, these examples are known as the unlabeled or unknown samples. Is it clear?
Yes, sir. Yes.
Right? So sometimes you have the D information, but you are hiding, you are not providing this information to the neural network. So that becomes the unknown sample. Unknown samples to the neural network. Although you know the actual value. Yes?
Could you please?
Yes?
Could you please explain it again if possible?
Okay. So I am gradually entering into the how to design a neural network, right? First thing is that, as I said, for each problem, you have to design the neural network first, and then you have to use that, right? So in the designing of neural network for a given problem, you must have a number of samples. Those samples may be known or unknown. So right now I am talking about the known samples or label samples. And second thing is that the samples should be from the different or from the multiple classes, not from one class. They should be from multiple classes. So taking that information, here I have written that you have given a n number of samples, label samples or patterns, right? Examples, patterns, item, all are actually synonymous, so whatever you can call them. So let's say you have given n number of label samples. That means the label sample set is capital X. So this is normal notation that you use to in mathematics or any scientific expression. X1 comma D1, then X2 comma D2. So X1 up to Xn comma Dn. Now X1, this is the sample, and D1 is its class level, the class information in which it belongs. Let's say if you are talking about the digits, so D1 will be either 0 to 9, any one of these 10 digits. Either the D1 falls under 0 class or maybe 1, any one out of 10. Similarly, for X2, class information is D2. D2 again, it falls any one out of 0 to 9. Similarly for Xn. And this not necessarily that, okay, the 0 items, for 0 the digits, that will be written first, and then 1 digits, then second digits, and then the last in the 9 digits. Not like that. It can be, you can arrange them arbitrarily, randomly, right? So if you have the if you have the x1 and d1 in that format, x1 is the sample or the feature vector of the pattern or sample, and d1 represents the class information. So this is known as the label sample. And if you hide or do not use the d value, d1, d2, that value, so that the sample that becomes unknown or unlabeled patterns. Is it clear to you? Okay. So question is how to make a neural network to understand the input-output relationship. So given, see here from the given set, you have the set x1, d1. So you know that for x1, the output will be d1. For x2, output will be d2. For xn, output will be dn. But how to make your neural network to understand this input and output relation, right? That means if you give x1 to the neural network, it should produce the value d1. If you give x2 to the neural network, it should produce the value d2, or it should recognize the x2 as a d2. So how you make it possible, right? So the solution is that, the answer is that you have to pass the neural network through learning or training process, right? So keep it in mind again. Given a problem, if I summarize, given a problem, you have to collect the samples from that given problem, right? And problem, obviously it should be for multiple class, and for each class you collect multiple samples, make it one, it may be the known or unknown sample. Better is it should have the known sample or label sample. But then you design the neural network, you make all those connections, and then using the label sample, you learn or you train the neural network. And once it is trained, then only you can ask your neural network to predict for the unknown sample. So design neural network, first thing is that training is must. Without training cannot be your neural network cannot give the satisfactory result. So training is must. Once training is completed, then you ask for you can ask your neural network to give output for the unknown pattern, right? So this is the sequence of steps. So right now, so what it does actually, training, as I said, that once you design a neural network, it has to be trained. So what it actually does? So in the training process, it is actually training or learning. It is a process that whether you take for the car driving training or whatever, it is a process by which the free parameter means those weights, that weights of the links, those are actually free parameters. These free parameters are updated through the by using the known samples, right? And once it is completed, those are actually recalled to predict the output of the unknown samples. Now this training is actually based, depending on the nature of the training, these training are usually the three types. One is or the most famous is the error correcting learning rule or supervised learning. That means in the training, your intention is that to reduce the error, right? So let's say again example, take the same example. You have gone to a training car training school. So whenever you learn you are in the wheel, you're driving, you are taking a training to learn how to drive a car. So every time your intention will be to reduce the error, right? Once your error that comes down to quite zero, near to zero, So your instructor will say that, okay, your training is over. You can get a license for driving a car, so that you can alone, without help of your trainer, you can drive your car alone in the city road or maybe any road, right? So this type of the learning rule or training process is known as the supervised learning. That means somebody is there beside you to supervise you, right? To rectify your error. Second one is the memory-based learning. That is, you recall your the memory, and based on the memory, you learn yourself, right? So that is something like I will discuss on that. And then competitive learning, which is unsupervised learning. You don't have any supervisor beside you, right? So you got some a set of no unknown examples. From there, you have to learn yourself. So that is unsupervised learning. Nobody around you to identify your error. You have to use yourself. So that is the unsupervised learning or competitive learning. Right. So let us come one by one. So if I summarize what is the supervised learning, what is given in the case of supervised learning? A set of level unknown, known examples of multiple classes, as I said earlier. What to do? Train the network using those level samples from the multiple classes. What is the assumption? A supervisor which is sitting beside you or guide that who will help you in the training process, and so that actual output is related to the input examples, right? So which will you have the supervisor which will guide you through the training process, so that you can actually you can predict the input output relationship. That means if you give this input, you get the proper output, right? So how it does? Randomly from the set that you recall the previous example, that set capital X, x1, x2, then up to xn. So from the set, you randomly take one sample from the set and give it to the neural network. Generate the output at the output layer, then calculate the error because your supervisor is beside you. So the supervisor will give you that, okay, you have taken this input, out should be this one, D1 or DI. Based on your output, you compute the error and then update according to the error value, you update the weight vector, right? And then again, you randomly take the second example from the set. Again, you compute the output, get the error, again update the weight vector. So like that, till you reaches once you complete all samples from the set, that is known as the one epoch. Sometimes you will find in the neural network that completion of one epoch. One epoch means if you are actually drawing one sample from the set one at a time. Once you complete all the sample from the set, once for each sample, no sample will be repeated in the second time. If you complete all the sample in one iteration, that is known as the one epoch, right? So if you complete the one epoch, calculate the average error, that was the average error for the complete set. Then if your average error is less than threshold, it should be greater than threshold, right? It is wrongly written less than threshold. If your average error is greater than threshold, you go to the step 1, otherwise stop. Is it clear? It should be greater than, not less than. Less than means your error is below the threshold. So that is completion of the training. It should be greater than threshold, right? Any question up to this? Students? Participants?
No, sir.
Okay, fine. Shall we take a break or shall I continue? 5 minutes or 10 minutes break, so whatever you prefer, I can.
Sir, as you wish.
Let me see how far we have. Okay, let 5 minutes break, right?
Okay, sir.
Only 5
Okay.
minutes.
Okay, sir.
ঠিক আছে ভর্তি হয় বন্ধ করবে কিন্তু না পুরো পড়বে Participants, is it okay to start?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So let us start. So as I said previous slide that this is the procedure steps. Randomly taking one sample from the set, giving to the network, generate output. Based on the output from the supervisor, you know the actual output, so calculate the error. Accordingly, you update the weight vectors, and then again randomly take the second another example from the set till you reaches the all samples from the set. So when you complete the all samples, only that is known as the one epoch. So like that, you have to complete many epochs, maybe in terms of few thousand epochs, right? In the case of face recognition that I worked earlier, so sometimes you have to go through the 15,000 epochs, maybe sometimes 30,000 epochs, right? So then only you can have the better result. So in mathematically, if you see here, so you have the given x, as I said earlier, x1, d1, all are level samples. Xi is xi to xm, m number of features, and w, these are the weight vectors or weights. That is also m number of, and then bias. So you give from the set, you take any one, let's say xi, that is given to the network. You compute the value over here, pass it to the activation function. You got the y value, any activation, usually the sigmoid function usually used. So you got the value, y value. Now from the, let's say you have given the x1. So you got the value y1 over here, right? And for the x1, sorry, for the x1, the actual value should be d1, but your computed value is y value. Let's say y1. Now, so from y1 and d1, you compute the error, right? So you got the error. Taking this error, you have to update the weights, right? You have to update the weight accordingly, so that your intention will be in the updation of weights is such that in such a way so that next time the error should be less than the previous one. Like for any training, whatever you take any field, your intention should be to reduce the error while you passes through the training process or training phase. Your intention will be to reduce the error. If you don't able to reduce your error, that means your training is not going properly, right? So your intention will be to reduce the error. So accordingly, you have to update the weights. So these weights actually in the form of knowledge. So is it clear? I am not going to details. I will give you some reference or name of those articles or the books from where you can find the details on that, right? So second type of learning is the memory-based learning. Now here is that, let's say the key idea what it says. Let's say that you know the input-output relationship from the past experience. Somehow you know the input-output relationship. Let's say from the level samples, you know that for x1 you have the d1 value. or in general xi di. So this is known to you, right? So this is plotted in the, let's say, graph. If it is in 2D, the xi is the two-dimensional feature vector. So you can plot them into a graph, and accordingly you know the d value, right? So this is if it is known, and then let's say you have given a test vector which is not seen before. It is a completely new one. So it is represented in the form of x test. So how to identify the x test? How to identify the x test? So it is so in here is it is based on the local neighborhood by examining the samples of your local neighborhood. So based on the local neighborhood, it has classified into two types. That is, one is nearest neighbor, and another is k nearest neighbor. Have you heard about the nearest neighbor classifier or k nearest neighbor classifier? I think so. Anybody working with the pattern recognition or classification, or maybe machine learning or something like that? Have you heard about the nearest neighbor classifier or k nearest neighbor classifier?
Yes, sir.
Okay, I think you will be able to. These are more popular and easy to implement. There is no need to use some functions or something like that. You can easily write some C program. Usually, I prefer writing C program. Everything that in my research, I never use for any Python function or the MATLAB function. Everything I suggest my students to write their own C program, right? Except the printf, scanf, all the inbuilt function, but everything, whatever in my research work, I tell my students to write themselves. Right? Even myself, I prefer to write program. Anyway, so the nearest neighbor. So from the known samples, from the known sample that is plotted in the graph, for an unknown sample here x test, you find the nearest one, nearest known sample. So how do you find the nearest? Which sample should be the nearest? How do you measure this one? So you have to find the distance. Take for the x test, you calculate the distance from n number of known samples which are plotted in the graph or which is stored in your memory. Now, so you will get the n number of distance. From the n number of distance, you find the minimum distance, right? You find the minimum, the samples for which you get the minimum distance. So for the samples, non-samples, you know that its class, So the class of X test will be the class of the nearest sample. Is it clear? So how do you find the nearest sample? Or how do you measure the distance? Have you heard about the Euclidean distance? Have you heard about the Euclidean distance? That is straight line distance. I think you might be in the Euclidean distance, right? That find the distance, near the straight line distance. If you draw any point to point distance, so that is the Euclidean distance. Now it works well when the known samples are independent to each other and the sample size is large enough. So in that situation, nearest neighbor rule works perfectly well. Second one is that you find the k nearest neighbor. So like here, this example, let's say, can you see the slide?
Yes, sir.
Yes, sir.
Yes, okay. Let's say we have this what says that from the test sample, you find k nearest neighbor. You, instead of the nearest neighbor, you find your k nearest neighbor. K may be usually the odd number. So out of k, you find that which type of sample that dominates the k number of nearest sample. Like majority voting, out of k, you find the which class that dominates among the k nearest neighbor. So that the class which is dominating, so you can say that the test sample will be the dominating class. Like this example, let's say here two classes, one is 0 class, another is 1 class, right? So these are the plotted points, non-sample, and let's say the D, this is your the test sample. Now, if you find the nearest neighbor, the D is classified as a 0, right? See the picture, slide. D is more closer than this 2A, 2, 1. So D will be classified as a 0. But if you take the nearest neighbor, k nearest neighbor, k means here, let's say k is 3. So you find the 3 nearest neighbor. So how many? So 3. What are those? 2 1s and 1 is 0. So out of 3, you find the majority class. Which one is dominating? Majority class. 1 is majority. Out of 3, you have the 2 1 class and 1 is 0 class. So in that case, you can say that D will be of 1 class, right? Instead of 0, although that 0 is the nearest neighbor, but in case of k nearest neighbor, the 1 class is dominating, right? 1, so 0 value is 1 and 1 class is 2, number of 2 samples. So you can say in that case, that is the D sample is of 1 class. But here is perfectly, because the 0, this is actually outlier. Outlier means by in some sense, with the help of some noise, it is plotted within the 1 class. So in mathematically, it can written like this: class of X test will be max Binet class of X1 to Xk. That means out of Xk, you find the class, how many the samples of each class, which one is dominating, to make it class of the X test, right? Is it clear?
Yes, sir.
Okay, then come to the third one. That is, as I said, that this is something new, that if you have the unlabeled samples, so you have the competitive learning, you don't have any supervisor or beside you anything that which may guide you through your learning process. So here, given training set, like here I have, although I have the D1 value, but I am not using those D1 value without the class information. So output neurons of a network. So how do you do this competitive learning? You don't have you are not using the class value. So in that case, the output neurons in the output layer, they compete themselves among themselves to become active, and according they will be able to learn the data. So basic element. Now the neurons are randomly distributed. These are the actually whatever. These are the some the points that you have to remember. Now here is that the output neurons, they compete among themselves. So since they are competing among themselves, sometime any one neuron will be winner. So the winner, the neuron which wins the battle among themselves, the weights associated with that winner neuron, you update those weights only. Other weights are remain same. So like that way, while you proceed through the epochs and the iteration, finally the neural network will be able to learn themselves. I'm giving you an example. Let's say, take this picture. This is your input vector xi. Let's say I've taken three inputs, and let's say these three outputs. So you give the input over here, input layer. You find the y value, y1, y2, and y3, right? Now you test the value of y1, y2, and y3. Let's say if y2 is greater than y1 and y3, right? y2 is greater than y1 and y3. So the links associated with this y2, that is the red links, the weights associated with the red links, those weights will be updated as we have done in the case of error correcting rule. And the weights with the associated with the y1 and y3, those weights will remain same. So update the links associated only with the y2, right? Next time again you draw another vector, input vector. Again you compute the y2, y3, and y like that. Again you check the which one is maximum. The winner neurons, you update the neurons, the weights for the winner neurons only. So in that way, many times you have to compute many epochs, maybe a few thousand in the form of 20,000, 25,000, 30,000. That time you will see that for a given input xi, you have the correct output in this output layer. Right? Correct output means for the output for which the maximum value. Usually the wherever you find the maximum value, that is the output of the input vector. So like here mathematically I can say, let's say the vk is the greater than the other value. So your yk value will be 1 and others is 0. So you update the value of the kth neuron. See the k neuron that is updated. The weight value remains 0. So that is 0. That for the other neurons, 0 is added to the previous value, and for the winning neuron, you are adding something. So that in that way, the neural network able to learn by itself. And these type of neurons usually do not use in the case of classification, but they are actually where you have given a number of unknown samples. You don't know the type of structure of the samples or data, but you have to get some idea that what type of data actually, how many features, how many classes they may have, what are the prototypes of those classes. So this type of neural network is used in these cases. Those actually that becomes the feature detector of different classes. What are the prototype of those classes? Because you don't have any clear idea, because you don't have given the class information, right? So these are actually used for the feature detector of different classes. What is the feature of the class value? So I'm not going to details. Anything you have, then I will go to the more well-known or deeper structure of the neural network from 2-layer to multiple layers.
Participants, any doubt so far?
Any doubt you have? So I can move forward. This is something in deeper way. So I'm going inside, right? From simple concept to the complex concept, which can be used for any problem at present. We have that varies from medical image segmentation, maybe face recognition, or whatever you can say, that is applicable for any type of problem. Okay, fine. Let's move on. This is the multi-layer perceptron, where you have more than one layer. Input layer is compulsory, output layer is compulsory. in between input layer and output layer, you have one or more than one hidden layer neurons. Right? So this is here the input layer and output layer. Again, I am keeping this C number of output neurons and M number of input neurons, and in between input layer and hidden output layer, I have kept this is one hidden layer. So they are all feed forward fully connected network, and this structure known as MLP, known as the MLP. Right? So again, the number of neurons in the input layer will be the dimension of the feature vector, and number of neurons in the output layer is the actual class of the problem you have taken in the hand, or for the class, actual number of class for which you are designing the neural network, and the number of neurons in the hidden layer, that K, that lies in between C and number of sample, capital N. Right? The number of K, that should be usually less than equal to capital N and usually greater than C. And the weights that is in between input layer and hidden layer, that is represented in the form of W, and weights between the hidden layer and output layer, that is represented in the form of Z vector. So W vector and Z vector. That's why they are written in the form of bold letter, capital bold letter. So they are vectors. Again, in the form, then you have the bias in the hidden layer as well as the output layer. So this is multi-layer perceptron structure, and this is trained with the help of an algorithm known as the back propagation algorithm or delta algorithm. Have you? I think you have heard about this back propagation algorithm, right? This is a well-known algorithm. Now, what it does, so for training the MLP, multi-layer perceptron, what you do is you need n number of level samples or patterns of C classes. So again, capital X, n number of training samples of level known sample or the level samples. Xi is 1 to m. Now, before giving randomly from the set to the network, you initialize those values, weight vector W and Z, randomly from a population of 0 mean, right? 0 mean, from a population of 0 mean. So this is the standard procedure. I think you know what is the 0 mean. So from a population, you have a number of values whose mean is 0, right? So you initialize the W and Z value, and then from the training sample capital X, you take any one, let's say, and give it to the network, right? And then you calculate the output at the hidden layer, like see here, W into Xi, V, and then you pass on through the activation function phi. Once you got Y value, that is the output from the hidden layer, then you come based on this, taking this Y value, you compute the output at the output layer. So you see, and then again you pass through the same activation function that will give you the output value. So once you got the output value, you calculate the error. So this is the output value from your network, and D value, you can remember the D value that you have with the training sample. So you calculate the error and just subtract the error, and then this is for all the C outputs. Then you find the total error at the output layer. See this one, summation of 0 to C. So this is find the total error. This is in the form of square. because why it is taking square? That if you, sometimes the error will be positive or negative, right? And if you sum up the error, you may eventually get the 0. So that does not mean you don't have any error, because the error, some error are positive and some error are negative. So that's why you got the total error is summed up error is 0. But that does not indicating that you have the no error. So that's why I'm taking it is square of this E, and this half divided by 2. This is actually for future calculation. I will show you that it will actually cancel the square term, right? And average error is the for all sample. Once you complete the epoch, so you find the average error, summation of zeta divided by n. So that is zeta average. So your idea is that, intention is that to reduce the zeta average less than the threshold. Once it is done in the training process, your training is complete, right? So here in mathematically, or if you go on details inside the computation or a computation in the training process, see here while any training phase, initially your error will be high. See the graph, the error correcting rule. Initially your error will be high. As you go on through your training process, through the iteration, right, your intention will be to reduce the graph. So this is your something typical error graph, right? So you have started from here, top of this error, and then you are going to reduce the error so that your error is close to 0 while you pass through the training process. So actually you are moving along the error graph towards downside, towards negative direction, not going to the positive direction. You are going to the negative direction. Why? Because your intention is to reduce the error, not to increase the error, right? So that's why you are going downside or negative direction of this error graph. So how to move? Every time you have to find the gradient. How to find the gradient? You have to take the first order derivative of the error graph. Now, why it is the non-linear? Why it is not the linear? See this one. You have taken the E square of error. So this is non-linear. So that's why your graph will be something like this type, right? So non-linear graph. It is gradually decreasing towards 0. So you have to, how to update those weights? You have to take the gradient, local gradient, and based on the local gradient, you have to update the weights. And the direction will be in the negative direction, going downwards. So you have to find you have to make the correction to the weights. Here Z, that is, the correction is proportional to the error. See the zeta with respect to the Z value. So that is proportional to this one, and that is, and if you, that will be equal to the minus. This minus indicates the direction of negative direction, not the positive going upwards. We are going downwards. So that's why this is a negative direction. That's why it is minus. And eta, this is the learning rate, right? How fast you are learning. So this is zeta. Usually it is less than 1 and greater than 0. Most preferred number is 0.05. Sorry, 0.25. Right? Now, if you do this one, because you are moving along the error graph, so if you do this calculation with if you find the tangent of error graph with respect to Z, you have this equation. Okay, I am not giving details of that. Finally, we'll end up with this, the delta, which will be corrected with the previous one or added to the previous value of Z, eta, delta C, N. So delta C is the local gradient and Y value. So this is your at the output layer. And then same way in the hidden layer, that your correction is the delta W. So if you do the same way, I have given this equation, same way, I have not given the explicit derivation of those calculation. So if you can do yourself with the equation, everything is given here. If you do yourself, you will end up with delta W will be again eta delta K xi. So delta K, yes. Anybody has the question? Okay, fine. So delta K is the again local gradient in the input to hidden layer. So in general form, the correction that will be given to the weight vector, that is weight correction, that is the learning rate parameter, that is eta, local gradient, that is delta, and input signal in that weight vector. So this is the general form. Now see here in the backpropagation algorithm, delta, this is the local gradient in the hidden to output layer, and delta K, this is input to output layer, and see this one, ZCK next weight value, next for the next iteration weight value, that is the previous value plus delta ZCK. See the same one, eta delta C YK. Similarly for W also same gradient, eta, local gradient, and input value. These are known as the sensitivity factor that determines the direction search in the weight space of W and Z. Right? So the detailed calculation you can get from the previous slide I have given you. You can yourself from the equation you can derive the equation. Right? So main thing is that along the error graph you are moving along the error graph. How? For the each point you are finding the gradient, and with that gradient you are not going upwards, you are moving downwards, because your intention is that to reduce the error. So that's why in the previous equation the minus sign is given. Right? So if you proceed that way, you will end up with this equation. So that is the behind the you will find that okay, how this equation come, right? So that was the concept, right? And what you find the average error. If your average error is less than the threshold, you complete, and if your average error is greater than threshold, you have to go for the next epoch. That means from the set you have to draw sample one by one and update the weights till you reaches the average error which is less than the threshold. So they are the way you have to complete usually few thousand, usually in multiples of 10,000, 10,000, 20,000, 30,000, something like that. Then your network will be fully trained, and once that is trained, if you give unknown sample, your network will be successfully, most of the cases, obviously not every cases, most of the cases around more than 95%, or maybe in general 90%, your network will be able to successfully classify the unknown sample and eventually recognize the sample. Right? This updation of weights, as I said, W value and Z value, it is sometimes known as the sequential mode. That means you take one sample from this set, compute the error, and then update the weights. This is called the sequential mode. And batch mode, you complete one epoch, and then you update the weights. Right? Obviously, the sequential mode is most faster than the batch mode. So these two modes, it is available. I remember that if you use some Python or maybe some module, built-in module or maybe freely available module, you have to select whether you will use the sequential mode or the batch mode with some parameter. Okay, but I don't prefer those taking module. So I prefer always writing some program by yourself. Now, if let us take one example, right? This is XOR problem. I think you know our XOR. If 0 0 or 1 1, your XOR value will get 0. If 1 0 or 1 0 1, your XOR will give you 1 value, right? So this is XOR problem. See the coordinate 0 0 origin, 1 0. This is 1 1 and 0 1. So 0 0 for this input you will get 0 value. For 1 1 you will get 1 value, 0 value, and 0 1 and 1 0 you will get 1 value. So how to recognize this one, right? Now seeing this one, can you draw a straight line by which you can distinguish this sample? Can you draw a single line? You cannot draw a single line, right? If you draw this one, 1 1 is classified in that way, that is 0. This way is 1, right? But this is not classified properly. Similarly, if you take this arrow, this straight line, this is classified correctly, but this is not properly classified, right? So what you have to do is you can use the multi-layer perceptor. See this one. This is for X and Y, because you have the only two inputs, 0 0 1 1 or 0 1 or 1 0, two values. And the output only because you have either 0 or 1, so one output neuron is sufficient. Now, as I said, the hidden layer neurons, number of hidden layer neurons is less than equal to capital N and usually greater than C. So here is the only one neuron, so it has I have taken 2. Now these are the weights, these are the initial weight, right? 0.5 plus minus 0.5. All weights are assigned as a 0.5. Now this neuron is bias neuron and upper neuron also bias neuron. And this is O is output value. And you have taken the activation function, that is this one. If the V value is greater than 0, it will be 1. If it is less than 0, it will be let's say it is 0, right? So after training, after so many epochs, this neural network, see the weights, it changed to this one. See the weights. Okay, see the weights. Now, if you give any value, 0 0 value, if you give here 0 0 value, with this activation function, you will get 0 output. If 1 1 value over here, X and Y, with this activation function, you will get 0 value. But if you give 0 1 or 1 0, whatever you get, you will get the 1 value. You can check with this final weight value, right? So by using multi-layer perceptron, you can easily solve the XOR problem, which is non-linear problem. Non-linear problem means you cannot separate the samples by drawing a straight line, but obviously you can separate them by drawing non-linear separable the non-linear the plane or the line, right? Separating line. Any question? Like here, see here, by the first hidden layer, you will be able to identify or successfully classify the 1 1. Again, by using hidden layer 2, you can successfully classify the 0 0, but not 1 1. But using both hidden layer neurons 1 and 2, you are actually able to classify this 1 1 as a 0 and 0 0 as a 0. And in between, you have the output 1. So that means it successfully solves the XOR problem. Any question up to this? Participants? Participants, do you have any question?
No, sir. Participants haven't sent any question in the chat box. I think you can continue with that,
Okay.
sir. Okay.
So this is the last slide, right? So that part I discussed the backpropagation algorithm or the error correcting algorithm or memory based algorithm or the competitive algorithm. So that is the training phase, right? You design, given a problem, you design based on the problem, you design the neural network with the help of known or unknown sample, you train the network. Now it comes to the testing the network, that whether your network is capable enough or whether your network is learned. Yes, we are talking about the machine learning. So with the help of a model in the form of neural network. So whether your neural network is learned or not from the given sample. So you have to test it. So train the neural network that we have discussed till now, and then take the feature vector of one test pattern, right, which is not given to the network till now, and put it into the input layer of the neural network, which is trained, just now trained. Now compute the output at the output layer. Now determine the class of the test pattern as the index of the output layer neuron, because you have in the output layer neuron, you have capital C number of neurons. So out of C output, capital C output, you find the neuron for which you are getting maximum value, right? So that's why I have written, determine the class of the test pattern. So you find the index of the neuron which is producing maximum output. So the index value, this index value is the class of the test pattern. So determine the class of the test pattern as the index of the output layer neuron whose output is maximum, right? Because you are mark the output neurons as a 1 to capital C or 0 to capital C minus 1, right? So if you are talking about the recognition of digits 0 to 9, so you can mark them 0, 1, 2 up to 9. So anyone you find the maximum among 10, 0 to 9. So which one is you are finding the maximum value, the index value 0 to 9, that is the class of the test pattern. So in that case, you know the actual class, because although you are not giving the actual class to the network, but you yourself, you know that for which class you are given the test pattern. So you check with its actual class. If it matches with the computed class, you call it recognized, otherwise not recognized. So like that, you repeat for all the test pattern, and you let's say out of 100, you got 90 as a 90 number of sample as a recognized. So your success rate will be 100 minus or 90 divided by 100 into 100. So 90%. So you compute the recognition rate. So like that. So that's the end of my talk. Any question you have? I will be happy to answer you.
Participants, any queries?
Participants, any query, any question?
I think everyone is very much clear.
Okay, fine. So what my final words is that you try to get some idea. Generally, what happens, from my long research career, I studied from long back. So what I feel, everything is that you try to develop yourself, right? Try to write some codes right? So that in that case, you will be able to learn something that what is going on inside. Not like that blindly by using some tool, some function and call it, and it will give you the result. That is okay, fine, but you will not be able to understand that what is going on inside. You cannot change your module. You cannot change the basic principle, basic algorithm, right? So I prefer always, I give my student, even myself, even I always prefer to write program. Usually, basically, I write in C program, in Linux, everything. Whatever if you find my research publication, whatever everything is written by ourselves, and in that program, C and Linux.
Sir, I have a query, sir.
Yeah.
It's a very wonderful session, and being a basic learner, I was able to get the fundamentalities of this neural networks. Can you please, can you please highlight me about the importance of neural networks applications in economics and finance, sir? Because I belong to that background, engineering, economics. Can
so
you please?
Economics means what actually you want to do?
No, I want to like as it is nowadays now as per the new educational policy of 2020, we need to be enriched ourselves with all these neural networks, artificial intelligence.
No, I am not. Let's say in economics, I am layman in the economics or something.
Like for example, renewable energy is there. Renewable energy. So in
one thing is that in neural network, as I said, most of the cases it recognizes, it classifies. Let's say for your economics, let's say for any data, let's say what is that?
Economic growth.
Economic growth or the share market, like that. Okay.
Yes, sir.
Right.
Yes. Yeah.
So there are so many parameters.
Correct, sir.
That gives you some idea whether that is positive or negative or something like that, or neutral.
Correct, sir.
Let's say the three different scenarios. One may go up, one may go down, or that may remain constant. So that varies on different parameters. So those parameters are your features vector. Features. Now for different parameters, you have to collect so many instances that may drive you upwards. That may you will get the green signal, right, in the share market.
Okay.
And again, for the negative direction, going for the possibility of going negative direction, going for the red direction downwards, you have to collect so many parameters.
Okay.
Right? So many instances of those parameters.
Okay.
Right? And also for the neutral one. Once you got that one, so that means you got the samples, training samples, maybe known or unknown.
Yes.
Okay. So once you got that one, you can definitely that will fit for you design the MLP. So that is come down to any problem. Like in as I said, the digit recognition or the character recognition or face recognition, whatever it may be.
Okay.
So your domain may be different, but once you derive those parameters, or derive those parameters, and you got the instances the samples that come down to the same category, irrespective of the domain, whether it is digit recognition or character recognition or maybe face recognition. Right?
Okay, sir. Yeah.
And then you go as you can. So that's why you can say that the data science, ML, machine learning, they are applicable for everywhere.
Correct.
Because they are deriving from the different domains. It is started with different domains.
Exactly.
Your economics, maybe our computer science, or maybe some physics.
Yes, exactly.
Once it is derived from there to the samples that I given the capital X, once it is coming to the capital X of the known sample or unknown samples, they actually belong to the same class. Okay, because it is originated from different discipline, but from there it is coming to same class, and you proceed with the neural network.
Thank you very much, sir, for your deeper insights. Thank you.
Any question, audience?
Participants, any other question?
Okay, I think if you don't have, although if you have any query in future, my email address is given there. Also, you can get from our Jadavpur University website. I will be happy to interact with you, right? I actually main thing is that instead of giving any, that's why I in the beginning of my talk said that don't take it as a general lecture. Try to understand the things what is going on inside neural network. That is the most important, as I feel personally, right? So once you able to learn something that okay, this way things are going on, you can change the algorithm. But the algorithm that I described in the backpropagation algorithm, that you can change according your concept or according your new thinking. So that's why that new learning algorithm will evolve, right? But if you blindly use the backpropagation, I think backpropagation algorithm is available in the Python as well as the what is that, MATLAB, or maybe some other scientific packages. My concept is that you write yourself, you change according to your requirement. Sometimes may not be useful for the MLP with the backpropagation. You need to change your algorithm, something different. So in that case, you need to understand the basics of backpropagation algorithm, what is actually going on, right? So that way.
Sure, sir. Sure, sir. Many participants are appreciating about the session in the chat box also.
Okay,
Thank you
fine.
so
That
much.
is my pleasure.
It was a very interactive and very informative session. Thank you so much, sir.
Okay, thank you. Thank you. Can I leave it now or?
Sure, sir. You can leave the meeting.
Okay. Thank you.
Participants, we would be meeting for the next session at 2:10. Thank you all.